Chapter 12 Scalar Products and Vector Products. In Chapter 11, we have already discussed how to do the addition and subtraction of the vector. In this part, we will discuss how to do the product of the vector, but there are two kinds of multiplication in vector. The first one is called scalar product, and then the second one is called vector product. Let's see their definition. First, I will introduce what is scalar product first. The definition of scalar product, or sometimes we will call dot product because we will use dot to represent the relationship between them. So, the definition like this. If we have two vector A and vector B, what is the meaning about A dot B? A dot B means we'll use the magnitude of A times magnitude of B times cosine theta. This angle must the angle between vector A and B. But how to determine the angle between two vectors? We need to move the vector from the same starting point, and then this angle is the angle between these two vectors. There are several remarks. First, you can observe on your left hand side is vector dot vector. On your right hand side, magnitude A is a scalar. Magnitude B is also a scalar. Cosine theta, for example, cosine 30 degrees is a scalar also. So we will say the scalar product of two vectors is a scalar. That means it is a values only. But what's the meaning about that values? It is the magnitude A times magnitude B times cosine theta. And we can discuss more what's the true meaning of this, the values behind, because one of a lot of application of the scalar product and vector product is we can apply in physics. For example, if A is the force and force is a vector, B is a displacement is also a scalar, and then force times displacement, which is equal to the work done. How to calculate the work done? Work done is a scalar. Then this is the work done, what we want to calculate. Second remarks, I mentioned before, remember we need to move the vector to find the included angle. That means the angle between the tail of two vectors is the angle between two vectors. And according to the definition, what is the meaning of A dot A? That means magnitude A times magnitude A times cosine 0 degree, because they are parallel. So the angle between these two vectors is 0, cosine 0 is equal to 1, so A dot A is equal to magnitude A squared. How about I dot I? I is a unit vector, so magnitude I times magnitude I, their parallel is times 1, so magnitude I is equal to 1. So 1 times 1 is equal to 1. So you can see there are several remarks. Remember, only I dot I, J dot J, K dot K is equal to 1. A dot A is equal to magnitude A. Sorry. This is magnitude A all square. How about I dot J? Vector I dot vector J is magnitude I is equal to 1 times magnitude J is equal to 1 times cosine 90 degree. Because this is y-axis and this is x-axis. This is vector I and vector J. The angle between vector I and vector J is equal to 90 degree. So cosine 90 is equal to 0. So you can see that I dot J, J dot K, or I dot K is also equal to 0. Let's see example 12.1. Okay, find A dot B. Easy. Why? Because A dot B is equal to magnitude A times magnitude B times cosine. Okay, let's see. Because this angle is between the tail of these two vectors, so it's cosine 30. And then 2 times 7 cosine 30, which is equal to 1 as root 3 over 2. And then after the cancellations, the answer is 7 times root 3. How about part B? I also want to find A dot B. A dot B is equal to 2 times 7 magnitude A times magnitude B times this angle. Remember, is not the angle between two tails. So we need to move this vector A to these positions. Magnitude is also equal to 7. So angle between A and B is equal to this angle rather than 60. That means this is cosine 120 degree. Cosine 120 degree, which is equal to 1 over 2, negative 1 over 2, 2 times 7 times negative 1 over 2, which is equal to negative 7. Try to do follow exercise 1, pause the video, and do it. Let's check the answer. A dot B is equal to the magnitude A times magnitude B times the angle between two vectors, which is equal to 150. So after simplify it, the answer is negative 2 with 6. How about B? Magnitude A is equal to 2, magnitude B is equal to 3. Angle between A and B, you need to move vector A to these positions and vector B to these positions, and then the angle between A and B also equal to 120. So negative 1 over 2, simplify it, you can get the answer. There are several properties of the scalar product. You may turn to page 3. There are several properties. First one, and some property is obvious. For example, A dot A. We mentioned which is equal to magnitude A squared. Magnitude must be greater than or equal to 0. So A dot A must be greater than or equal to 0. According to the definition, A dot B is equal to vector A magnitude of A times magnitude of B times cosine theta, which is equal to B dot A, because magnitude B times magnitude A times cosine theta, which is equal to magnitude A times magnitude B times cosine theta. For those properties not very difficult to prove it. For example, 0 times vector A. This is 0 is a scalar 0 vector dot A, which is also equal to 0 because 0 vector the magnitude is equal to 0. And so maybe we will apply it one by one. But the most important or the most obvious most frequency we will use is property D. How to simplify A dot vector B plus C, which is equal to A dot B plus A dot C. Maybe you will think that this is obvious, but in vector field, that means in this topic, we have a new definition about this dot, which is equal to I can introduce in this way. What is A dot B? A dot B plus C, which is equal to magnitude A times magnitude B plus C times cosine angle between A and B plus C. But this is equal to magnitude A times magnitude B times cosine phi. This phi is angle between A and B plus magnitude A times magnitude C times cosine maybe alpha. Alpha is the angle between A and C. This result is marvelous. It's not obvious to see this result, but some mathematicians they try to prove it, and then you can also refer to the following proof. But I will not go through it with you because some property we will discuss later. For example, how to simplify this term later, and we'll discuss it. For example, H seems very difficult, but if you draw the diagram, not very difficult to see it. If we have vector A and vector B, what is A minus B? So this is A minus B. So after I draw this diagram, can you think about the relationship? Okay, if you cannot imagine, let's come back and we'll discuss together why this property is satisfied. Okay, let's see how can we make good use of those properties. Example 12.2, prove A minus B dot A plus B is equal to magnitude A minus square minus magnitude B square. You need to very familiar with all property, then you have some direction or some hints to do it. For example, in this case, I know how to simplify left hand side. According to property D, A minus B dot A plus B, we can distribute it just like what you learn in junior form. So which is equal to A dot A and then plus A dot B minus B dot A and then minus B dot B. It is because A dot B is equal to B dot A, so subtraction, eliminate, so cross out, and then A dot A, which is equal to magnitude A all square minus magnitude B square. You may pause the video and then try to do for exercise 2. One typo. Help me to amend it. It's not vector P and Q. It's vector A and vector B are perpendicular. Show this part. Please pause the video. You may need to use at least 5 minutes to think about these questions. Try to determine which property you can use and simplify it. Okay, let's check the answer together. Maybe first you need to think about why we need how to apply these informations. If A and B are perpendicular, what information we have? This topic is related to dot product. If they are perpendicular, that means this angle is cosine 90 degrees, which is equal to 0. Then, second thing you need to consider is left hand side or right hand side we can start. Which part we can start? For example, on your right hand side, this is magnitude A square plus magnitude B square. You can only change to A dot A and B dot B, but you cannot do anything. But on your left hand side, magnitude A square is equal to magnitude A plus B all square. We can change to A plus B times dot A plus B. Simplify it. A dot A and then A dot B plus A dot B and then plus B dot A, this is done, and then press B dot B. Whoa, very good. Because I know this time is equal to 0, and this time also is equal to 0, because they are perpendicular. Then done. Left hand side is equal to right hand side. Okay, this is the end of the first part of the video. Let's continue our discussions in our lesson.